Without further ado, let's begin our video by discussing claims from credible scientists that the latest data from the James Webb Telescope reveals a universe that extends beyond the Big Bang. That's right, some scientists suggest we've found evidence of a universe existing before the Big Bang. In an interview published on September 20, Nobel laureate physicist Roger Penrose, who evaluated recent research, added fuel to the fire by stating that if we delve deeper into the Big Bang, we may find traces of a universe preceding it. Additionally, we see that some popular YouTube science channels have also been publishing content suggesting that the universe began before the Big Bang. So, to get to the bottom of it, we reviewed all these publications to bring clarity to the topic. This claim challenges everything we know, so we'll explain each element in detail. As a result, this video will be a bit longer than usual. Let's begin by explaining the concept of the universe's expansion without leaving any room for doubt. In 1921, scientists discovered that the universe was expanding by observing the motion of galaxies. To better understand this expansion, imagine an infinitely large, blank sheet of paper representing the fabric of space. When scientists talk about the universe expanding, they're referring to this fabric stretching and growing. To illustrate how this expansion works, let's imagine placing two galaxies on this expanding space. As space expands, you can see galaxies moving further apart. You might think this expansion started from a specific center, but that's not the case. Observations show that expansion occurs everywhere, indicating there is no single center of expansion. In fact, wherever you stand in the universe, it seems like everything is moving away from you. This is the nature of expansion. Anticipating a question from the comments, some might wonder, if the universe is expanding so quickly, why are the Milky Way and Andromeda galaxies getting closer? The answer is simple math. The rate at which these galaxies are approaching each other is greater than the universe's expansion rate. Now, let's continue. Not only is the universe expanding, but scientists also observed that the further a galaxy is from us, the faster it recedes. This discovery suggests that space isn't just expanding, it's expanding at an accelerating rate. If you travel 3.26 million light-years outward, galaxies appear to recede from us 68 kilometers faster. Considering Earth as the universe's center, scientists have found that, beyond a certain distance, space-time expands faster than the speed of light. You might wonder if this phenomenon violates the famous rule that nothing can exceed the speed of light. Einstein's rule applies to objects traveling within space, not space itself. What's happening here is that space itself expands faster than the speed of light, which is consistent with the laws of physics, or at least that's how scientists explain it. We leave it to you to decide whether this explanation is acceptable. The age of the universe, the timing of the Big Bang, and our entire cosmological model rely on this rate of expansion. The expansion rate is expressed as the Hubble constant, the average rate at which the universe expands. In recent years, cosmic microwave background observations have estimated this value at 67 to 68 km/s, leading to an estimated universe age of around 13.8 billion years. Since ancient times, we have observed the universe and tried to uncover its secrets, often imagining it as infinite. However, the observable universe has a boundary defined by the laws of physics. In other words, even with a telescope as large as the solar system, there is a limit to how far we can see. This boundary is known as the Hubble sphere, which, for us, is approximately 48 billion light-years in diameter. Within this sphere, galaxies continue to recede from us, but because they move slower than the speed of light, their light still reaches us. Some light from galaxies beyond the Hubble sphere started its journey billions of years ago and is only now arriving. This suggests that the Hubble sphere expands over time, allowing us to see increasingly distant regions of the universe. However, the Hubble sphere won't expand forever. Beyond a certain point, galaxies are receding so quickly that their light will never reach us. In conclusion, we have long understood that there is a limit to how deeply we can observe the universe, known as the observable universe, with a diameter of about 93 billion light-years. Another mystery that makes the universe even stranger is that when we look at its distant regions, we are actually peering into the past. This is because light takes time to travel across space. For example, if we observe something 1 light-year away, we are seeing it as it was 1 year ago. The farther we look, the further back in time we observe. Scientists have so far been able to look back up to 13 billion years with powerful telescopes, building models to show how the universe appeared at different times. Looking more than 13 billion light-years away, we reach the Dark Ages, when the universe was shrouded in dark hydrogen gas. According to the standard cosmological model, if we could look to the edge of the observable universe, about 13.8 billion light-years away, we would witness the universe's first moments, the Big Bang. Scientists believe that, at the beginning, everything was compressed into an incredibly tiny point, a singularity. We cannot fully understand what this singularity looked like, as our current scientific theories fall short. Just as the observable universe limits how far we can see, the Big Bang limits how far back in time we can look. Many scientists believe that beyond the Big Bang, there is simply nothing. The claim at the center of this video is that new observations from the James Webb Space Telescope have found evidence of a universe existing before the Big Bang. This rumor emerged while scientists were using JWST to study a supernova known as SN Hope to measure the universe's expansion rate. The latest data from this supernova suggests that the universe is expanding faster than previously thought. It's this surprising measurement that has led some to speculate that the expansion of the universe may have started even before the Big Bang. However, this study is currently archived and has not yet been peer-reviewed, nor does it directly reference the Big Bang. Instead, it focuses on the expansion rate, specifically calculating the Hubble constant, estimated at 70 to 83 km/s/MPC, much higher than the previously accepted value of 68 km/s/MPC based on cosmic microwave background data. Using the new value of 83 km/s/MPC instead of 68 km/s/MPC gives an estimated universe age of 12.5 billion years instead of 13.8 billion, suggesting a discrepancy that might account for a pre-Big Bang universe. Yet, these fresh and unverified data mean that no one has ventured to assert this conclusion outright. Support for a pre-Big Bang expansion comes from Nobel laureate Dr. Roger Penrose, who believes the universe's expansion could have begun before the Big Bang. Inspired by Penrose's theories and this recent research, we've created this video to explore the uncertainties in the Hubble tension, unexpected star and galaxy discoveries, and how these topics challenge our current cosmology model. All sources and references are available in the description for viewers to explore and form their own opinions. With this video, we shared the latest on JWST and the Big Bang. Although there is no definitive proof yet of a universe before the Big Bang, there are compelling reasons to believe that such evidence may emerge soon. Until next time, stay tuned.